about that person's life, and because they aren't here, there's something that they've done wrong. Maybe they just couldn't coordinate. Maybe they just couldn't come. Okay, 1-1-12, right? Never assume, because sometimes people just can't come because they can't. Okay, it says how many diagonals can you draw? Oh, what's the total number of diagonals in the 35-sided polygon? So when you look at a polygon, you could have a 3-sided polygon, and a 4-sided polygon, and a 5-sided polygon.
That is so cool.
I know, it's totally not fair.
It's not.
And a 6-sided polygon. And then your diagonals would be like, let's put those in there. No diagonals here, 2 here, and then, right, 5 here, and then here you've got diagonals, so you could go to each vertex and connect, and you can kind of see the symmetry.
Good morning, staff. Just to let you know, Sam is here from Mountain Man, so come on down. He's in the lounge and gather up your goodies.
Okay, look at each vertex to make sure you have them all. There's 3 diagonals coming out of each vertex, right? So you should make sure that you have the same amount, like sprouting out. Okay, when they ask you to figure out for a 35-sided polygon, you should never, ever draw much more than what I've drawn. Okay? You laugh now, but you should see some of the tests I get. Somebody's still going to try to do, like, it takes up the whole paper. So for a 3-sided polygon, there's no diagonals. For a 4-sided, there's, and for a 5-sided, there's, for a 6-sided, 9. Okay, good enough. When we look at the pattern here, we're going up by 2, then up by 3, then up by 4. And so we know, since it's not going up by a constant factor, that it's not linear. So we're going to look for a multiplying pattern. It's going to be a quadratic, because the second time it goes up by 1. So 2 things. You should be able to figure out what the next one is, up by 5. So if it was a 7-sided figure, you'd have 14. And you should be able to figure out the rule for n, which takes a little bit more work. Okay? So far, so good? One at a time.
Yeah.
Well, okay, but let's make sure everybody, one at a time. Dave?
How come you started at 3 for the side?
Because it says polygon.
Oh.
You need 3 sides.
Okay.
Brigitte? So do you see where I got the numbers from?
Yes, but I do not get like numbers like that. Yeah.
Okay, you don't get what? How to figure out the pattern?
Yeah.
Because when you extend this line here, like if I just, extended the lines, I just get, I didn't really want them, but I'm going to have them dotted. I'm just going to extend these columns so we don't lose track of what goes with what. So I understand what you're saying. Like, it's hard to find, for example, there's lots of ways to get 0 with multiplying. One way to get 2 with multiplying, and only one way to get 5 with multiplying. So there's no way to get a pattern here, right?
Yeah.
Because if it were the top pattern, you'd have to have 1, 5, 9 times 1, but you're not making it any better than it was because you have the exact same number, right? So what we do in that case is we try doubling. So if I think of 2 as 4 divided by 2, and think of 5 as 10 divided by 2, and think of 9 as 18 divided by 2, then when I make my rule over here, it's going to be something divided by 2. Because I'm going to make a rule, and the 2 is in everything in my rule. So I have to put my 2 in the rule. So what I'm going to do is try to find a multiplying pattern for 4. So I could like say 1 times 4, and then I want to get a multiplying pattern for 10. 2 times 5, 3 times 6,
Oh,
because I'm trying to get a pattern for the 4 here.
Yeah, I know, but why are you doing why the 1 and then you go to the 2 and then?
Because I'm trying to get a pattern. So if you look, there's a pattern for 1 to 2 to 3, isn't there? It's a linear pattern. So I'm going to put that first linear pattern in my first set of parentheses. So 1 to 2 and 2 to 3, they go up by 1, right? So my coefficient of n is 1n. And then I look at my n value, like pick an n value, like 5.
it can be any n value.
No, you can pick any one. So 1 times 5 is 5, but I need the 2 down here. Do you see that? So if I use this 5, I have to look down at this number 2. How do I get from 5 to 2? I have to subtract 3. Check it here. If I made my n value 4, 1 times 4 is 4, but I need to get all the way down to this 2. I mean to this 1. What's in yellow? So, do you see how, if I did this one, 1 times 6 is 6, but I need to get to the 3. 6 minus 3 is 3.
Oh. Wait, but listen.
Okay, one at a time. Will,
How would you find like the multiplication? Like, how would you know that it's 1 times 4?
you have to kind of play with it.
Okay.
So I give you more practice in class today.
When it goes up consistent.
Yeah, right.
Oh, okay.
So Connor,
So is that the one thing you have to do, or do you have to do the second one?
I have to do the second one too, right? So my second one is 4 to 5 to 6, so that's going up by 1, right? So it's still a 1n. But now if I look at this, 1 times 6 is 6, but now I need the 6. So it's done. Yeah, check it here. 1 times 5 is 5. I got the 5. So your rule, it's kind of squished in there, is n times n minus 3 over 2.
Multiplication for this stuff is hard.
Well, you gotta work hard. Sorry. And then for 35 sides, you just do 35 times 35 take away 3 divided by 2. So that's 35 times 32. I don't know. Divided by 2. So really that's 35 times 16, right? Because 2 goes into 32 16 times.
It's not something like 35.
No. Thanks, 516.
That's a lot of
I know, that's why you didn't want to draw the picture. Cool.
Will did that differently, but it like took way less time. So
Well, because you might have some things memorized, right? Did you notice it was related to the handshake problem, or
no, we did it like a kind of different method.
which is okay. Here's the only, like you probably saw a problem with the polygon, right? So I get that, but what if there's a problem? Yeah. What if there's a problem where there's no picture? Because you might, like what if I said, here's a new table, okay? So let me just draw a new table. And I said the table was I don't know, the zero term. Okay, and we have 2, 9, 20, 35. And you have to figure out the rule for n and the 20th term.
Good morning, good morning, good morning, and welcome to beautiful Colorado sunny weather.
So Cole, now you have no picture, right? So you can't rely on a picture. So if you can rely on a picture, and I can put a picture to this in a minute, but what if you don't have a picture? Okay? What's your strategy? Okay, so while you're doing that, can we decide if it's linear or not? This is going up by 7, then 11, and then 15, right? So the second difference is constant, right? 4, so that tells us it's quadratic, which means it's two linear patterns times together. Leah.
Is one of the multiples, is one of them always n?
No. They don't always is probably never going to happen. There's not always the same thing happening.
So like most of the time?
I don't, not necessarily. Don't, in that case, you just don't know. So what you're going to do is look for a multiplying pattern. So you want to try, and I'm going to extend my lines because I get a little sloppy, right? So I know what goes with what. So I'm going to just start with 2. 1 times 2. Then what?
3, or no, wait, can you do it the other way around?
You could, or 2 times 1.
And then 3 times 3.
3 times 3.
And 4 times 5.
So look what he's doing. 2, 3, 4 times 5. Brigitte, do you see how we picked that? Like I started with 1 times 2, and then he's like, well, can I say 2 times 1? Because he was already thinking ahead. 2, 3, 4. Can I do 5 times something to get 35?
7.
7. And it's going up by odd, so I'm going to make a rule for this first. And in this case, Leah, the rule is n, because it is the same number. You see that?
Yeah.
It's going up by 1. So the rule is 1n. And then when you check it, like 1 times 2 is 2. Ah, now what's wrong? My n is 2, but it's not the same number. You see?
Yeah.
So you have to do what here? I have to get from 2 to... Here's something I like to say, you guys. Once you find these products, I cross out all these other numbers because you're not going to use them again. That really helps me.
Okay.
Like I'm using the product, so stop looking at all of this stuff. Just use the n. So it says 1 times n. So 1 times 2 is 2, but I have to get this 4. Yeah, so there's a case where it didn't always end up just being plain n. I almost thought it was going to, but it didn't. Okay. So let's look at the next one. So Brigitte, see the next one? What it's going up by? What is it going up by? 2's, right? So that 2 becomes your second coefficient. 2 times n. Now check it, right? What's 2 times 2? Because that's your n value. It's 4, but we want 5. See, we want to get these numbers now. So plus 1. So check it with a different n. What's 2 times 3? But I want... And did I double this time? So I didn't divide by 2. Okay? So I'm going to just stop that because it's short, right?